Hello, and today's purpose of the day is I can solve radical equations. 10.4 Radical equations. If you square both sides of a true equation, then the resulting equation is still true. Let's look at a couple facts. If a equals b, then a squared equals, what do you think? If a equals b, then a squared equals b squared. If the square root of x equals 4, then the square root of x squared equals, what do you think? If the square root of x equals 4, then the square root of x squared equals 16. So, just recapping a few facts on square roots and squaring. Our goal today is to solve radical equations. So let's try to solve for the variable any way you can. So the first goal is to solve the equation. And the second goal would then be to write a step-by-step process of how to solve any radical equation. Give it a shot. Hint, there is only one solution for each of these equations. Good luck! Okay, I hope you had some success with the equations, but if you didn't, let's go through a step-by-step process of how to solve radical equations. First step is to isolate the radical. So let's look at example 1. We have the square root of x minus 3 plus 8 equals 15. So we first must isolate the radical by subtracting 8 to both sides. So I'm left with the square root of x minus 3 equal to 7. So that was step 1, isolating the radical. Step 2, square both sides. Now let's think about this. Why would squaring both sides be helpful in this case? Well, to get rid of the square root, we would square that item. So x minus 3, the quantity being taken the square root of, if we square all that, again the square root will just cancel out with the squared. So I must square the other side, and then I'm left with on the left-hand side of x minus 3 equal to 49. Now I isolate my variable by adding 3, and I get x equals 52. So we just solved in step 3 after we squared both sides. Now let's check our answer. So I'm going to plug 52 back in for x and see if I get the correct answer. So if I plug in 52, I have the square root of 52 minus 3 plus 8, and that had better equal 15. Well, 52 minus 3 is 49, and the square root of 49 is 7, and 7 plus 8 does equal 15, so this works out, and we are correct. So remember, when squaring both sides, you must square the entire side of the equation, even if there is more than one term on the side. Let's look at example 2 because it's slightly different. We still want to follow the same steps of isolating the radical, squaring both sides, solving, and checking our answer. Because here we'll see something a little bit different. So I want to isolate my radical. So as I look on the left-hand side, I see the square root of t plus 5 equal to t plus 3. So my radical is already isolated. That square root of t plus 5 has nothing else with it. It's just by itself. So let's go right to step 2, and let's square both sides. So I'm going to square this side, and I also must square the second side, or the right-hand side. So when I square something that's being taken the square root of, I'm left with just t plus 5, and that equals. Now here, I don't just get t squared plus 9, I actually have to go back in, FOIL from chapter 8. So if I FOIL that here, let's just recap. T times t is t squared plus 3t plus another 3t plus 9. So I get t squared plus 6t plus 9. So I'll write that in right here. Now I have to solve. So we're going to be solving this quadratic equation. Let's move everything to one side. So I'll subtract t, and at the same time I'll subtract 5. So then what I get is 0 equals t squared plus 5t plus 4. Now, what method should we use here to factor to solve this quadratic equation? You guessed it, diamond method because a 1 is in front of our t squared here. 1's our coefficient. So factors of 4, that when added together give me 5, are 4 and 1. So I must set t plus 4 and t plus 1 equal to 0. So what that looks like is, again, t plus 4 equals 0, t plus 1 equals 0. So my two solutions are -4 and -1. But let's check our answer from step 4, and then we'll talk about this green writing in this box here at the right. So let's go back up to our equation. Whoops, don't want that. Back up to our equation, and let's check our answers. So we came up with the solutions of -4 and -1. So here I go, if I attempt to solve this. So let's plug in -1. So -1 plus 5 would be 4. So square root of 4 equal to -1 plus 3 is 2. Square root of 4, 2 equal to 2? You bet. So -1 works out. Now let's check -4. So I'm going to erase this here so I can put a new color in. Okay, so -4 plus 5 is 1. And the square root of 1, is that equal to -4 plus 3 is -1. So let's put this over here. Square root of 1 equal to -1. In this case, for radical equations, the square root of a number can only equal a positive number. So the square root of 1 has to equal 1. So this would not be true, right? I want to put a line through this, no solution, but it doesn't work out. So the square root of 1 cannot equal -1. It can only equal +1. So in this case, we come up with what's called an extraneous solution. And an extraneous solution here is, when we solve radical equations, we get equations that aren't actually solutions to the original equation when we go back and plug them in. So because -4 here doesn't work, that is what's called an extraneous solution. So the only solution to this quadratic equation would be the t equals -1, because when we plug that in, that successfully worked out and fit both sides of the equation and made that equation true. So -4, I could cross that out, or I could write extraneous. Okay, let's take a look at a word problem. So example number 3 says an object is dropped from an unknown height and reaches the ground in 5 seconds. Use the equation t equals square root of h over 4, where t is the time and h is the height in feet, to find the height from which the object was dropped. So here's my equation, t equals square root of h over 4. I need to isolate h and figure out what that height will be. And what I know is that t equals 5. So I'm going to substitute 5 in for t, and then set that equal to square root of h over 4. And now I just have to isolate my radical, back to those steps that we already wrote down. So how I would isolate the radical is I would multiply by 4 to both sides, and then get 20 equals square root of h, and then again, the over 4 canceled out. And now I just need to, again, isolate h, so it's being taken the square root of. So how do I undo something that's being taken the square root of? Well, I square it, and I have to square both sides, so I get 400 equals h. So my answer would be 400 feet. But let's plug this back in and make sure that this works for the equation. So t equals the square root of 400 divided by 4, and the square root of 400 is 20, and it's 20 divided by 4 equal to 5. Yes, it is, so this satisfies the equation. For when the time was 5 seconds and that object was dropped, it must have been from the height of 400 feet. Thanks for listening. Have a great day. Please check Google Classroom for more information. Bye-bye.